Welcome back, viewers. We're going to pick up a part 2 of installing this into an AC4 power supply. Grab onto something, hang on, it might be a bumpy ride. When you start a project like this, make sure your workbench is clean. That's how you do it in my shack. Now we got a clean workbench. We'll get the AC4 power supply up here and take it apart. One of the first things we need to do, and I shouldn't even have to mention this, but in a world where you can sue somebody for selling them too hot of a cup of coffee, unplug it. Step number 1. Through the magic of video editing, found the appropriate drill bit, and now we just zing the screws off. They're tiny little suckers, so to keep from getting lost, I use these things. These are magnetic screw holders. I get them from Harbor Freight for a couple bucks a piece. Keeps the screws in. That way I won't lose them on my desk. Trouble is, I've got about a dozen of those things all over the shack, full of screws from various projects I have long since forgotten what they were. So sometimes the solutions can be worse than the cure. Thank God they used screws in here and not top rivets. Oh, that would be terrible. Okay, now then the top should come off. Run on, get off it, stinker. Oh, cobwebs. All right. Doesn't look too awful bad, but we still got to take the bottom off. Looks like it's taking a hit. There's a little bit of a buckle there, probably from a UPS shipment. Most people don't know how to package heavy stuff like this. And let's see, a little screwdriver. Oops. Getting old. I forgot screws on the cap. All right, let's try that again. Just work yourself around the edge. Another one I forgot. Oh, Nike was getting on you old getting so old. And now we got the bottom off. Now before we go any further, I have to let everybody know, especially those who've never had their fingers in one of these things, they will kill you. First off, AC mains, 120 volts, almost unlimited current. You get across that, you're dead. Second up on our tour of horrors is the plate supply voltage. Normally runs about 750 volts. You get across that, you will die. And it will hurt while you die. Third up is a screen supply. Runs about 350 volts, thereabouts. And that will knock you across the room and could potentially kill you. Don't touch that. The bias voltage is around minus 70 volts. And that will make you clench your fist up, jam your arm up into something, and just ruin your day. So what we're going to do and then is we're going to discharge the capacitors. This thing hasn't been turned on in probably 20 years, but just to make sense, or make sure and make sense, we're going to discharge the caps, and I'll show you how to do that. Those two large capacitors are the plate filtering capacitors and a big screwdriver. Go from the chassis and touch it and touch it. Now, normally, if there's any juice left in these buggers, you'll see a spark and you usually hear a snap. It can be startling, so be aware that when you short out the capacitors, you could see a little bit of flash and awe. However, you can also take your handy dandy little multimeter, negative the chassis, and see if in fact there's any juice there, which of course there's not. And while we're at it, we'll check up the other capacitors. Nothing there. No. This thing is about as dead as it can possibly be. But always check, always discharge the capacitors. It will really make your day if you don't. This is where the fun begins. We need to take all the parts out that we don't need anymore, such as diodes, this capacitor, resistor, and work our way down over into the low voltage bias section. Now in the past, I've always told people in the kit, you don't need to take these out, physically take those out. They're like old relatives just hanging around doing nothing. So if you want to leave them in there, you certainly can, but they'll be electrically disconnected. And we'll just give a good old clip here. Tell you what, this is hard to do, looking through a viewfinder. Well, you sure can tell those things have had some hours on them. We need to take and remove a couple of wires right now. First off, we're going to take this white with orange tracer, and we're going to solder that. I'll make a liar out of me. All right. That was plan B. We need to also move this red wire. Now, let me get this guy out of the way here. Sometimes I think you're better off clipping the wire because I'm not melting too much insulation. Sometimes these come right off of there, and other times, nope. All right, get him out of there. Now then. Oh, that's nasty. Take it, put him. Oh, there's the dogs. Yeah. And we're going to put him back in this slug right here. Now that's a really miserable solder connection, but right now there's another wire goes there, so we're not going to worry about that. Basically, what you're going to do now is disconnect all of this mess and take these capacitors out. We'll take, clip some of them out. And get out there, you stinker. You don't have to be really too neat about this. The only part you have to really be cautious with is the leads on this pot, because although it's only like a 10K pot, you can't hardly find them anymore that have the tab mounting. And now all we have to do is to trash the capacitors, and I'll do that off camera, and we'll pick it up in a little bit. I've taken the resistors off of the terminals, and most of the time all you have to do is heat the lugs up and the part will slide right out. They're not mechanically crimped. Now you notice the green wire, that guy should come off of there. I might have to end up cutting it. Oh, there we go. The green wire. This gray wire, you can leave it go, but we need to cut the, that's already cut, okay. The yellow wires and the blue wire needs to come off there. And let's see if I can't maybe get him to cooperate. Hey, okay, all right. Make my day. Ooh, I'm impressed. That wire we can cut off. Okay. Now then, we've got a pretty good little gutting out here. Take the yellow wire back out of there. There's a yellow wire here. This needs to come off. Okay. Now then, like I said, I'm going to pull those capacitors out of there. See this guy here? It's soldered in. It takes a really mean soldering iron to get those come loose. So what I do, I break off these twist locks, and then mechanically rock the capacitor back and forth till I metal fatigue the tab, and it'll come out. These two here have got screws in. We'll take those off from the top. The capacitor by high voltage has got one of those soldered on there as well, and you can do the same thing. Rock it back and forth till metal fatigues and the tab breaks. When we come back, we'll have the caps out. All the capacitors have been disconnected, and they will end up going in the trash. All that's left now is some wires, and we need to tidy up a couple. This orange and white wire, I should say white with an orange tracer, that can be disconnected. We don't really need him anymore, so just less trouble. I also took some solder wick and I cleaned out the ring terminals so we can put our new wires in. And next step, we need to take that nut, and that nut needs to be removed so we can put the mounting brackets in under the transformer. Got the mounting brackets installed. The mounting brackets go on top of the transformer tabs. Don't put them underneath the transformer tabs. Also, it's a lot easier if you put the mounting bracket in first, then drop the screw and washer on top of it. Trying to put the washer and screw in first, then slipping the mounting foot in, it's a lesson in frustration. Well, we've got most of the hard part done. We got the caps out, all the parts we don't need. Got the mounting brackets put in. By the way, I use a 1/4 inch drive with a 5/16 socket to take out the 1032 hardware for that transformer. Next thing up, put this into the power supply, And the first thing we're going to do is put hardware in the bottom. It says top. Well, obviously that goes up. And we'll do that and come back. Here is the mounting brackets holding the PC board. You have one of those small offset screwdrivers. This is the place to put it to good use. If you leave one of the sides of the PC board unattached, you can swivel it out and use the other as a hinge. I'll show you that later in a little bit. By removing one of the bolts, hardware, from the other corner, you can tilt the PC board out. Some people find it easier to do the wiring, but if you do that, whatever size you free up is going to require a longer wire or it won't tilt anymore. Just a head up on that one. Okay, let's have some fun. The first wire we're going to put in is a black ground wire, and that goes in the pad that says ground, and right below it there's a pad that says gray. Some Drake power supplies had black wires, some have gray. This one has gray. Doesn't make any difference because the pads are connected together. Gray or black doesn't make any difference. It also doesn't matter if you take and solder from the top or the bottom. I prefer soldering from the top, and we will do that right now. I can see the thing. Oh, there she goes. All right. And then we just clip off. Now, where you route that to kind of depends on. I'm going to take it right down this hole. Give yourself a little bit of slack. And that's going to go to the gray wire, which is connected to the chassis, which is obviously ground. So give yourself some slack and pull that off of there. And let's see. Okay. Shit, easy. We're gonna take and see if we can. Oh, killer PC board. We're gonna see if we can't clean up that solder connection right there. Yips. Out of there, you stinker. Now then, we're going to stick that wire, tighten up the twist a little bit, right through that molten solder. All right. Now then, we're going to make a mechanical connection, bend this thing back a little bit. Like so. Nice mechanical hair there. Now we'll take and add some solder to it. Nice and shiny. And there we are. First wire done. The object is to take a wire one at a time. Next one up will be the orange wire. Goes from the pad that says marked orange, and that pad then goes down to the orange wire that comes from the multi-wire cable that goes to the radio. And let's do that. The orange wire, which I've already soldered to the printed circuit board, comes up to this location, which surprisingly connects to the orange wire. I'll give it a little bit of slack, cut it off, and strip it back. Okay. Twist them together. You don't want any hairs on this one. Now you don't want hairs in any of them. Now I'm going to take a little bit of solder wick and see if we can't clean that connection a little bit. Okay. Oh, there's a lot of solder from the factory. Good heavens. I think we can get the wire through there. And then the orange wire, go through the hole, loop it back, use my finger, give it a squeeze, and solder a connection. There we go. The orange wire, obviously, is the same wire that goes to the plate voltage on the multi-conductor cable. And we shall move on to the next wire. Next up, red wire. Now this is the high voltage AC that goes back to the two red wires we disconnected and moved earlier. What I like to do is take the wire, loop it over. These two go to the circuit board, red A and red B. I think it was red and red A. Oh, I'm off my pills again. The red loop of wire, both ends go to the PC board. One goes to red, one goes to red A. Loop goes through the hole, and then I just cut it at the loop end. And that connects to the two red wires that we have on the terminal strip. That's the secondary, the high voltage secondary. What we're going to do now is install one white wire to the pad that says bias wiper. That will complete all the connections on that right side of the board. And we'll do that now. The white wire from the pad that says bias wiper goes to the center wiper lug of the bias trimmer. Now, I took a little bit of solder wick and sucked out the solder on those terminals. This thing is probably 40 years old, so that's very delicate. You don't need to make too much of a mechanical connection. Like the factory, they just stuck the part in through the hole. So that's what I did. Put the wire through the hole and solder it in place. That completes all the wiring on that one side of the printed circuit board. We're back underneath the chassis again. This is the yellow wire from pads yellow A and yellow B and the loop. Now what we have to do is take one wire, it doesn't make any difference which one, and connect it to that yellow wire. Okay, so we're going to cut the loop right there, cut the wire I should say. And the other wire, the remaining length, and let's see, we'll strip this guy back a little bit here. All right, give him a couple of good twists, stick him in the solder lug. Oh, you stinker, you. There we go. Looping back around my finger. Okay. Give it a nice good old squeeze. And we'll solder him home. All right. Now then, move this a little bit. This thick yellow wire actually comes from the transformer. Go into this lug, make a mechanical connection. There we go. The yellow wire from the yellow wire from the printed circuit board gives us a little bit of slack. Cut that. Strip the wire back. Got a little twisty. Stick it in the hole. Okay. And we'll solder that up. All right. So what we've got, this is the high voltage AC that goes back to the two red wires to the printed circuit board. The yellow wires go back to the low voltage on the pads yellow A and yellow B. Now then, this yellow wire, which is from the radio harness, we're going to connect that to this terminal strip I installed off the camera. And we're going to, well, I'll tell you what, let's see if we can't melt him back a little bit. Alrighty. I'm going to stick him in there. Right, probably. All right. Use one of the screws for the old capacitors to hold that solder lug in. And next thing we need to do now is run another yellow wire, which you have left over from that long yellow one, from the PC board to the solder strip. So while we're looking on this, we'll just stick a wire through there. Oh, you stinker, you. All right, be that way. We'll wrap you around it. I'll cut that little bit of a line lead off. Okay. That goes back down through this hole. And that connects to the yellow pad. All right, we connected the blue bias wires. One we connected to the lug. This is from the transformer. This goes on to either the blue or blue A pad on the printed circuit board. The second blue wire from the transformer connects to a blue wire that goes either blue A or blue. Doesn't make any difference which one you use. It's AC. The only wire we have left now is the green wire, which I'll connect down here. And we have two bias wires go to the bias adjustment trimmer. And we're almost done. Okay, that finishes it up. We've got the green wire, which is the bias, going to the pad green on the printed circuit board. The bias A and B goes to the trim pot. Let's see, we got the yellow wire. Yellows, blue and blue. Over here, we got the red, and yellow and red. Well, about the only thing we need to do now is triple check it again and then plug it in. Well, the moment of truth has arrived. All the wires have been soldered, double checked, triple checked. Even had the Pope pray for me. Now this part is kind of dangerous, and if you don't know what you're doing, for God's sakes, get somebody who will help you. Because there's no power switch on the AC4 power supply. It relied on the switches in the radio. And you could say, well, why don't I just plug the power supply into the radio? Well, boy, if you made a wiring error and you send 800 volts into the bias circuit, it's 1-800-FIX-ME because you just trashed your transceiver. We don't want to do that. So, as dangerous as this big sound, this is probably about the best way of doing it, with one exception. And that is to short out the power plug. And I'll have to look that up and tell you which pins it is. It's also in the manual you get with the kit. But short that out, basically turns the power supply on. Now when you do that, there's no indicator, there's no light, there's no meter, there's nothing that tells you that the power is actually on. You might hear a little bit of a hum, but that's about it. Now, when you do that, and you plug this thing in, it becomes deadly. And if you plug it in, and you hear something snapping and crackling, you see smoke, you hear the transformer growling, you have any other bad mojo coming off that thing, you unplug it as fast as you can. Also, before you do anything else, take the fuse out of the holder, like that, and verify it's actually what's supposed to be in there. Because I've seen 20-amp fuses in there. And there goes the dogs. The power supply is plugged in, it's turned on, and it's working. So, trusty Fluke 75 millimeter. Remember I said about leaving those little wire tabs coming out of the printed circuit board? Well, they make for really good places to test the voltage. So, let's see. Negative lead of the power supply, right there, connects to this yellow clip lead. And let me see if we get you a better shot here. We'll go to the orange pad. 715 volts. Oh, that's impressive. Okay. Oops. Whoops. Now then, let's slide this thing over this way a little bit. Yellow is our screen voltage, should be about 350. Put this meter here so you can take a look at it. Oh, there's those crazy dogs. Volts, that's good. The green should be bias. Negative 53, that's good. That actually is working just fine. Well, that completes the assembly of the AC4R printed circuit board into the Drake AC4 power supply. Now, remember a little bit ago, I told you there was a second way to take and test the power supply without putting that jumper into the plug. I came up with this thing. That is my universal high voltage power supply test set. And we're going to turn it on. I'm going to set the voltage selection to plate. Power is on. And if you'll see in the meter, that shows the plate voltage just about where the Drake AC4 should be. Let's select screen voltage, and it shows the screen voltage, the bias, and the filaments. And you can shut the power supply off. And when you go back up here to the plate, you'll see that the bleeding resistors are doing their job and discharging the filler capacitors on the plate. Same thing if you go down here to the screen, it's also discharging the screen resistors. Turn it back on. Back up to where it should be. Now, you probably don't need anything like this if you're only going to build one AC4 power supply rebuild kit. But this thing will actually work for Heathkit, HP23s, Galaxies, NCR power supplies, just about any high voltage power supply up to 1,000 volts. It does it safely, and all you have to do is plug it in. Power supply, test set. Don't have to touch anything else. It's kind of neat. So anyway, I hope you enjoyed the trip. Hope you enjoyed the journey. Hope you don't mind me mumbling through it. I have enunciation like that of a garden rake. So, quotes, comments, criticisms, and like they always say, please like, subscribe, hit the bell, or do whatever you have to do to make this thing work on YouTube. I'm still learning all this stuff. 73, I'm Mike, WB8VGE.